station. This is Houston. Are you ready for the event?
Station is ready for the event.
CNN, this is Mission Control Houston. Please call station for a voice check.
Station, this is Neha Shastri. How do you hear me?
Ms. Shastri, I have you loud and clear.
Great. So my first question is, I'm really curious, how does it feel for you from where you are to look at Earth right now?
Well, you started off with one of my favorite things to talk about, and that's the view back at Earth. I think that human beings, sometimes we explore just so we can look back at where we came from and understand the context in which we live. And there are no words I can accurately put to describe the feeling of being able to look out a bay window and seeing all of the world and all of everything that you've ever known and every person that you've been close to and every experience you've ever had in one glimpse of the eye. We fly over more than 90% of the Earth every single day. And so you think about your entire life and everybody you've ever known and everything you've ever known is you can take in with your eyes in one orbit. And it's overwhelming, it's awe-inspiring, it's a view I wish every person on Earth could have so we could understand our home better.
What did the first time you looked back at Earth, what did that feel like?
Well, the first time that I saw Earth out a window was actually on the Soyuz spacecraft right after launch. So I had a small window to my right side, and when we first got into orbit, it was nighttime, and so out my window there was just blackness, and I didn't really know what to expect, if anything, out that window. But 10, 15 minutes later, something caught my eye, and I looked out the window, and there was what looked to me like a small blue flame piercing across the window. And I didn't really understand. I didn't understand the context of what exactly I was looking at. But I watched it move, and suddenly I realized that I was watching my first sunrise from orbit. And that blue light just pierces across the surface of the Earth, and it just outlined the Earth, and it was absolutely awe-inspiring. And I looked over at my crewmate, David St. Jacques, who had a very similar view out of his left window, and the looks on both of our faces, we didn't even have to speak. It was absolutely incredible.
Does it compare to anything you've ever experienced before?
It certainly was a unique experience for me, and it was a very personal experience for me, because not only was I able to see this view of Earth that so few humans have had the privilege of seeing, but for me personally, it was also a culmination of a lifetime of dreams. I first told my parents I wanted to be an astronaut when I was only 3 years old, and I'm 39 and launching. That's 36 years of working toward a goal. And the view was overwhelming, but the emotion of understanding I was finally there was equally overwhelming.
That sounds like a truly amazing experience. Can you tell us a little bit more about the international collaboration on the ISS?
Absolutely. This space station would not exist if it wasn't for the partnership across so many countries, space agencies around the world. Every single day, we touch experiments, hardware that were built by, for instance, the Roscosmos, the Russian Space Agency, the European Space Agency, JAXA. Right now, I'm standing in the Japanese experimental module. We call it the GEM. And the partnership is what enables space exploration, and in the future, it's what will enable deep space exploration. To me, it's very humbling to understand the strengths that each agency and each country brings to the table. The experiments that we deal with day to day, I'll pick up the radio in the morning and I'll speak with the European Space Agency, and an hour later be speaking with the Japanese Space Agency. And the fact that so many people can work together to enable operations of this magnitude, I believe, is a symbol of what we can do when we set aside differences and we focus on common goals. And something that's been very humbling for me to recognize is that our common goals are far more than any of our differences. And quite honestly, it's only when we kind of do outreach and speak with people that we're reminded that we're different, because day to day, when I work with people from these different space agencies, I find people that are more like me than a lot of people that I've met my whole life.
Wow. What are you currently researching up there, and what do you think the implications of your research could be for the future?
Well, I'm going to change the question just a little bit. I'm going to say what we are researching. So me personally, I touch multiple experiments every single day, but I want to tell you about a few different experiments, because one of the things about the International Space Station, there's something for everybody. No matter what your job is, no matter what your interests are, we are touching your life in some way. And I really encourage people to get out and look at the ways that we do that. And you can find so much information on the NASA website. But everything from Parkinson's disease, for instance. We have one experiment called protein crystal growth, where we're looking at the pathology of Parkinson's disease. And we have millions of people on the ground who are affected by this disease, but the protein crystals don't grow large enough on Earth for us to accurately investigate the causes of the disease. And so we are growing the crystals out here on Space Station in a microgravity environment that they can study out back on Earth and hopefully understand the pathology of Parkinson's disease. If you're a physicist, if you're interested in what does the universe look like, we have the alpha magnetic spectrometer outside of the space station that's looking in deep space, and it's looking for evidence of antimatter to understand how did the planets form. You know, planets and hard bodies are less than 5% of our entire solar system, so what is everything else? Where did it come from? For the future of spaceflight, we are investigating ourselves. How does the human body react in the space environment? So, for instance, one experiment that we've been working on lately is called fluid shifts. So we understand that without the pull of gravity, the human body, or the fluids inside of my human body are in different places than they would normally be on Earth. I have a higher intracranial pressure. How does that affect my eyesight? If I land on the surface of Mars, if I'm up here for a year and I land on the surface of Mars, what is my vision going to be? So those are just a couple of the experiments, but it's everything from the human body to the physics. We look back at the Earth. You know, we do experiments from the International Space Station looking back at Earth that can help farmers understand how to better irrigate their fields, more efficiently irrigate their fields. Water planners to, spectroscopy, which can help water planners understand if it's going to be a drought year or if they're going to have a little bit more water. And so really the research that we're doing on the International Space Station touches everybody across all industries, and so the question really is what is interesting to each individual person, and then I really encourage you to go check out some of the experiments on NASA, because I guarantee we're touching your life every day.
That's so incredible to hear how the research that's being done up there is impacting what's going on here on Earth. You sort of touched on this, but I'm just kind of curious why you think it's important to explore space.
Yeah, and again, the answer to the question on why we explore is such a fundamental human question that I would turn it back on every individual that's asking that question and saying, what's important to you? Because that question is going to be very personal. People are driven by different things. If you are in a commercial industry and you're wondering, can you monetize this? Yes, go look at our commercial space opportunities. Look at how exploration done by NASA historically has impacted economies. What happens when we have an educated populace? The economies are boosted. Maybe you're one of those people that are related to somebody that is struggling with Parkinson's disease, and understanding that we are doing very real research on the space station today, this week, that can answer scientists' questions within years. That makes a really profound difference to people. Or maybe you still remember that little kid in you that would look up at space and say, what's out there? That fundamental need to explore, to look past where we are right now. And maybe you can look up at the International Space Station and you can see that it looks like a star moving across the sky, and you think, for 18 years we've been sustaining human life continuously in this dot in the sky, and think about all the technologies and collaboration that go along with that. And I think naturally humans have always had this propensity to explore. We went across lands, we went across waters when we explored the whole Earth and we started flying, and now we're going to space exploration. And deep space exploration is next. It's not whether we're going to do it or not, it's who's going to lead it. And so the question really, I think that's important to say is, who are we if we stop exploring?
Well, thank you so, so much for your time. This was such an incredible conversation.
Thank you. It was nice talking with you.
Station, this is Houston ACR. That concludes the CNN portion of the event. Please stand by for a voice check from NPR.
This is Lulu Garcia Navarro at GDS from NPR. How do you hear me?
I hear you just fine. Have a good day to you.
We are here today, and we wanted to give you a special hello from Georgetown Day School. We have a kindergarten class, so here they are. Give a big hello. I don't know if you can hear that, but we wanted to talk to you from a classroom today because we read an interview with your mom who said that according to family legend, you announced on your first day of preschool that you wanted to be an astronaut. Is that a true story?
That is an absolutely true story, and you know, you can't make it up. I told her that I was going to school to learn to be an astronaut, and that was my focus. And you know, maybe she was a little disappointed that I didn't run back to her like a lot of kids do. I just said, okay, I'll see you later. And by the time I was 5 or 6 years old, I wrote a little book, like we had a school project, and I wrote a book about flying to space on the Soyuz vehicle. So dreams and maybe even predictions do come true.
What was it like when you finally got into space after that lifelong dream?
You know, it is such a profound experience in my life. I will probably spend the rest of my life trying to find the right words to describe it, and I think words almost do it injustice. It was this combination of complete awe of looking back at the planet and understanding the context in which I had lived for so long was suddenly gone, and I was in a completely different environment, totally reliant on so many thousands of people in the different space agencies to keep me safe. And then there was just the human side of me it was the first time in my whole life that there was no doubt that I would get there because I was already there. I think up until the moment that you launch, so many of us are thinking, you know, maybe there's a reason something's going to happen. I'm not going to go. I'm going to have a medical issue. You know, they're going to delay the launch. But when you are finally in space and you're finally looking back at Earth and you realize for the first time in your life, there's nothing standing between you and your dream, it's just so hard to describe the profound impact of that.
So can you tell us what you are seeing right now when you look outside the window? Where are you flying over?
Well, since we started this interview, we have flown a quarter of the way around the world. We fly around the world 16 times a day, so very quickly moving. So I haven't looked out the window since I started speaking with you. But we cross over 90% of the Earth every day. We have a sunrise and a sunset every 45 minutes. And by far my favorite thing to see that I've been surprised at is watching the moon rises and moon sets. Because the moon moves so fast in the sky, you can literally watch it, because it's our nearly 20,000 mile an hour speed combined with the rotation of the Earth and the moon's orbit, and it just moves so fast. It's like it jumps off of the horizon and up and over us, and it's just my favorite thing to see.
So the class can see you on NASA TV right now, and they can see that, you're floating. What's the coolest thing that you can do while you float?
Well, I tell you what, every day is a good day when you're floating. There is no task that I don't enjoy more just because we're floating. It's your whole life you spend walking around Earth, and then all of a sudden you get to fly like you've dreamed of. And we try to do all sorts of tricks. We try to see how far we can fly without hitting the walls. And sometimes I just like to do some work upside down. Maybe I'll do the rest of the interview upside down just for the kids in the classroom.
I think they'd really enjoy that. I have a couple of questions from the children. I think they'd really enjoy that. I have a couple questions from the children. What do you eat, and what's your favorite food?
Well, what we eat up here, everything has to last for a long time because most of the food that we're eating today came up to the space station about 6 months ago. And we also can't have food, you know, if we sat down with a bowl of rice like we would on Earth, right? All that rice would just rise off the plate. And so we eat everything out of pouches, and we have two types of pouches that we fly. One is what we call shelf-stabilized food, which is just, it's like a pouch that you open up and you can spoon out and start eating it. And so my favorite food, we have a great chicken with a peanut sauce that's really good. We have chicken fajitas that are really good. We can put things on tortillas, and that kind of holds it in one place, so it can have the chicken fajitas. And then the other type of food that we fly up is dried food. And so we use this water on the space station to rehydrate that food. And so some of my favorites are the mushroom soup, and we have a great turkey tetrazzini. So we have a huge amount. I think we have over 100 different kinds of food. And so they try to keep it so we don't get too bored with the food up here.
Here's the question number 2. How hard is it to sleep in space?
That is different for everybody. So I sleep about 6 or 7 hours a night here. I sleep a lot more than that on Earth. And I don't think it's because I'm uncomfortable. I think it's because when I kind of wake up in the morning, I'm so excited to be up and to be in space that I just want to start my day and get going. So sleeping is very interesting. You know, you kind of just float inside of your sleeping bag and you attach your sleeping bag to the wall. Otherwise, you'd float around to the other side of the space station, or maybe one of my crewmates would play a joke on me and pull me out and move me somewhere else. So I attach myself to the wall. And then our arms kind of float up. So when you don't, you know, flex any muscle in your body, your arms kind of float up. So we look a little bit like zombies. And I'll tell you, one of the greatest experience that I had when I first got onto the space station was waking up in space. You know, because you wake up with that groggy, you know, you don't always know where you are. It takes a minute to kind of cage your brain. And the first day that I woke up in space and I was floating was a little bit interesting. It was a little disorienting.
One last question. Where do you think these kids will be traveling to when they're your age? What is the future of space travel?
Well, that answer lies in what they want to do when they're my age, for sure. I think that the future of space travel is going to be Mars. NASA has already set out a plan, a step-by-step plan on how we're going to get there. Proving ground, the International Space Station that I'm on right now is one of our proving grounds. The moon will be another technology demonstration and proving ground. You know, and then we're going to be looking at Mars for deep space exploration for humans. Now, robotic exploration, you know, we've already sent spacecraft beyond the farthest planets in our solar system. And so by the time they're my age, I think it's hard to predict where we'll be. You know, maybe we'll have the first humans that are living long duration, you know, years on Mars. Maybe that's open to everybody. Maybe we have tourists on different planets. Maybe they'll just take a trip to Mars with their family and then come back. It's hard to predict, but it is an exciting time. And in the context of history, we are in a very exciting time, and we're on the cusp of a lot of very unique space exploration.
Do you have any message for your fans here back on Earth?
Absolutely. I tell you what, you really can do anything that you put your mind to. And I knew I wanted to be an astronaut already when I was your age. And so the dreams that you have right now very well could be in your future. And the biggest thing is to not give up. No matter what anybody tells you, no matter what circumstances are sent your way, no matter what happens, you stay focused on that goal. And if you stay focused on that goal, you can shape your life in that direction.
Class, we want to thank astronaut Anne McClain joining us from the International Space Station. Everyone say thank you. Thank you very much.
Station, this is Houston ACR. That concludes the event.
And thank you, CNN and NPR. Station Houston, we're resuming operational audio comm.